Guys, today we are going to discuss about the orthogonality signal. So basically in a signal and system, orthogonality signal, what do you mean by the orthogonality signal? Basically we have a signals, write it down, signals x1 of t and x2 of t are said to be orthogonal if integrations minus infinite to infinite, the product of x1 of t into x2 of t from minus infinite to infinite integrations means if you are doing x1 of t into one will be conjugate. Okay, one is a x1 of t signal and another we have to take the conjugate of x2 of 2 signal conjugate, and then we have to integrate the whole product, and if you are getting the function as a 0, then the signal is known as orthogonal signal. This is the condition of orthogonality. Okay, and this is for we can say this is for imaginary signal. Okay, in a real signal what you will get, there will be a no conjugate, because in a real signal x conjugate will be x conjugate only. Okay, so condition for, write it down, condition for orthogonality for real signals x1 of t and x2 of t. If you have a real signal, then you will get minus infinite to infinite x1 of t into x2 of t into dt is equals to 0. Wait, someone is coming. Yeah. So this is the condition for orthogonality for a real signal. Priyanka, I just discussed about the orthogonality signal. x1 of t and x2 of t are said to be orthogonal signal if you have integrations of x1 of t into x. If you have a two signal x1 of t and another signal is x2 of t, and if you are doing the conjugate, means if you are doing taking a conjugate of one signal and multiplying with this and doing the integrations over a dt part, you will get the integration part is 0. That means you have a orthogonal signal. And for a real signal, if the product is coming to a 0 integrations, okay, then the signal is known to be orthogonal signal. By example you will understand these things. Okay, and for a real signal it's happen for orthogonality. What will happen in a real signal? Area you will get, just wait, you will get the area of x1 of t into x2 of t. If you are getting 0 in a real signal, then that signal is known to be orthogonal. Like I will give you one particular example. You have a example, see, you have one signal and this is your x1 of t. Okay, and here you are getting a curve like this, like this, like this. Okay, so 0 2 3, this part is 0, this part is 3, this part is 5, this is 2, this is 3, and this is 11. Okay, now if I am saying, suppose I'm taking another signal, x2 of t signal. I'm taking x2 of t signal. So from this part to this part, I have 4 value, then 2 value, it's coming, then I'm getting minus 1 value. Okay, this is 4, this particular is 2, this particular is minus 1, this is 5, this is 3, this is 2. Okay, when you just wait. Okay, I have to make this was 2, this was 3, this was 11. Okay, so when you multiply this two signal, then the new signal result what you will get, 4 to the 8 will come, 8, 3 into 2 you will get 6, and minus 11 into minus 1 you will get minus 11, right? And this is your 6, and this from here to here 0 to 2, and this 2 to 3, and 3 to 5. So overall area, this is the product, this is what, this is the product of x1 of t into x2 of t. What is the area what you are getting? Area, what the area you will get? First area 1, 8 into 2, 16, right? So 16 you will get, the first area you will get 16. So 16, this part, it will come 16. This part, how much it will come? 16 plus 6. Difference is 1 only, 16 plus 6. And this one will be minus 2 into 11. So 16, 6, 22 minus 22. How much you are getting? 0. So what is the meaning? This x1 signal into x2 of t signal, we are getting area, we are getting 0. If this thing is happening, that means these two signals are orthogonal. This particular two signal are orthogonal. So by graph what you say? By graph what you say? Area of x1 of t into x2 of t graph, if you are getting 0, then x1 of t and x2 of t are orthogonal to each other. So this is the one concept. And where we are using the orthogonality, write the next heading, use of orthogonality for energy and power signal. So how? In a calculations in a calculations we use. So if x1 and x2 are the orthogonal signal, if x1 of t and x2 of t are orthogonal, and if z of t, means z of t particular signal is the product of is not product, it's x1 of t plus minus, if x1 of t plus minus, wait, just give me a minute, I'm getting one call. Write it down, x1 of t plus minus x2 of t So the power signal you will get Pz will be Px1 of t plus Px2 of t, and energy will you will get Ex1 plus Ex2. You can directly add. So this is the concept of energy and power signal. Just wait, just give me a minute. Yeah. So this is the concept of orthogonal signal. Means you can add the signal. Means if you have a two particular signal, you can directly add the signal. Okay. So this is the small concept of orthogonal signal. I hope you guys understood these things. Uh, let me discuss the next part. Up to here it is clear, Priyanka? Okay. So see, suppose this was the small concept. Yeah, what I told you about the orthogonality. Yeah. So some important results, trigonometrical results, you can say. Write these things. Some important trigonometrical results. So see, I am giving you one particular example. Like you have a signal T naught is there, sine signal m omega naught t plus some phi dt. So phase, this phi is what? It is phase. And what, and m is your an integer value. And omega naught is what? This is 2 pi by t naught. So fundamental frequency. Okay. So fundamental frequency, and t naught is your time period. Okay. And harmonic we can say, see harmonics I will tell you later. This m, it's whatever the value. If you are putting 1, so it will be your fundamental. If you are putting it's 2, so it will be second harmonic. If 3, third harmonic. So harmonics, it's fundamental multiple frequency. Okay, fundamental multiple frequency, mental multiple frequency. So it's depend upon this m term. Okay, 1 2 3, it's depend upon this m term. Okay, you will get always this result as 0. In an overall time period, if you are integrating the trigonometric function, you will get 0. Average value of the any trigonometric function will come to 0. So same result for cos. This is your time period, cos m omega naught t plus phi into dt, you will get it as a 0. Okay, and what the things will come if you are getting a result t naught, that is sine square m omega naught t plus phi into dt. So this will come, this will not come 0. In this you will get t naught by 2. Okay, so this is one important function you need to remember. You can derive also sine square theta formula. Cos 2 theta minus cos 2 theta formula is equals to cos square theta minus sine square theta. So cos 2 theta is what? Cos square theta minus sine square theta. Then you can find the value of a sine square, it will become 1 minus 2 sine square theta. So cos 2 theta minus 1 or 1 minus cos 2 theta by 2, you will get sine square theta. You can substitute these things and put the value. So you will see that 1 by 2 value is coming, because this cos 2 theta integration will become 0. So 1 by 2 and 1 will be replaced by t naught. So you will get t naught by 2. So like that we are getting this result. What about the cos square function? Same result will come. So t naught function, cos square m omega naught t plus phi into dt, you will get the same function, t naught by 2. And suppose if you are having a multiplication like t naught, and if you have a multiplications of a sine terms, sine m omega naught t plus phi 1 into sine n omega naught t plus phi 2 into dt. So if these two signal are orthogonal, graphically how you will check? If the multiplication of this area is giving a 0, then it will come 0. Okay, how you will know that this function and this function are orthogonal? When your m and n are unequal. When m and n are unequal, that means your signal is orthogonal in this kind of a function. Okay, like for example, you can note it down. For example, z of t, you are getting 2 sine 2t plus 30 degree, and you have another signal 4 sine 5t minus 45 degree. Okay, so now you need to find the power and energy of this signal. So how you will do it? So see, this 2 and this 5 are unequal, means m and n are unequal. If we'll do the integration of this kind of a signal, we'll get 0. That means it's an orthogonal signal. So power pz of this will be this power and this. So power of the trigonometric functions, how we had got for sine function, what we do, we need to find the RMS value only. So this is my 2a square by root 2 the whole square. See, what is the formula for finding the RMS? So 2 divided by root 2 the whole square. Okay, and there we for power we don't need to find the RMS. We are doing the square of RMS. So we are getting the square of RMS. This done, power for this done, and this same 4 by root 2 the whole square. So what the final value you will get? 4 by 2 plus 16 by 2. So 20 upon 2. So 10 will come. Right. 10 will come. So the answer for this will be 10. Similarly, sixth one, just write it down. You have a trigonometric function cos n m omega naught t plus phi 1 into cos n omega naught t plus phi 2 into dt is equals to 0. This is true when m is not equal to n. Okay, then only it will be orthogonal signal. So suppose you have a z of t 2 cos 3t plus 45 degree minus 4 cos 7t. So what will be the power of this? Power of this will be how much? 2 divided by root 2 the whole square plus, you don't have to see the minus sign, minus 4 divided by root 2 the whole square. How much you will get? 4 by 2 plus 16 by 2. So 20 by 2, 10 will come in this also. And now if you are having a terms, suppose one term is t naught cos m omega naught t plus phi 1 and another is sine n omega naught t plus phi 2. This will be 0 again, means see, in this kind of a situation when you are getting a two different function cos and sine, so when it will be 0, this can be true for when m is not equal to n, and if it is equal, if your m is equals to n, if your m is equals to n, and if phi 1 is equal to phi 2, then both will be orthogonal. So in this kind of a situation you have to check two cases. If this m is not equal to n, then to it's fine. If it is coming, if m is coming to equal to n, then you have to see the phase. If phases are same, then it will be orthogonal. Like for example, you have a beautiful example. Z of t is 2 sine 3t plus 4 cos 5t minus 30 degree. So how we can say it will be orthogonal or not? Because our m is not equal to n. This 5 and this 3 is not equal to. So what will the power signal? Same, 2 by root 2 the whole square plus 4 by root 2 the whole square. So 4 by 2 plus 16 by 2, 10 I am getting. Okay, and if suppose you have a second example, if you will take z of t is 2 sine 3t minus 45 degree, okay, minus 3 cos 3t minus 45 degree, then see m is coming to n, but your phi 1 is also equals to phi 2, then also it is an orthogonal signal. So then if anyone is asking you power, so power will be what? 2 by root 2 the whole square plus 3 by root 2 the whole square. How much you will get? 4 by 2 plus 9 by 2. So how much you will get? 13 by 2. 13 by 2 is 6.5. Okay, so you need to note one point. Harmonics of a different frequency harmonics of different frequencies irrespective of their phase will be orthogonal to one another. Okay, so harmonics of a different frequency, it means m is not equal to n. So there is a no dependence of phase, that is phi 1 should be anything and phi 2 should be anything. Sine and cos function of the same frequency and the same phase are always orthogonal. Here you have to consider the phase. Here you need to consider the phase. Sine and cos function of same frequency and same phase are also orthogonal to each other. Okay, and one particular example I am giving you. 8th, so this is a t naught function, this is a naught, this is your sine m omega naught t plus phi 1 into dt. This function will come 0 because this is to dc value and this is your sinusoidal value, so it will be orthogonal. If you are multiplying any dc signal with a sinusoidal signal, it will give you orthogonal to each other, means dc value and sinusoidal value are orthogonal to each other. Okay, so for this write one example. If you have a signal 2 plus 8 sine 3t plus 30 degree, you need to find the power. So power will be, for a DC signal, 2 by 1 the whole square because it is a DC and this is sine wave, so 8 by root 2 the whole square. How much power you will get? 4 plus 64 upon 2. So how much you will get? 32 plus 4, 36. Because these two are orthogonal to each other, then power can be directly added. Okay. Second example. Example 2. Z of t, you have 2 plus 3 cos 2t plus 4 sine 3t minus 30 degree. Then see, here the signals are three signals, one signal, second signal, third signal. So these two are orthogonal because one is DC signal and one is cos signal. And for means if these are the orthogonal signal, you have to, and these two are also orthogonal to each other, this and this, you have to see whether these and these are orthogonal to each other or not. See m, see n, so m is not equal to n, that means it's orthogonal, all are orthogonal to each other. You need to find power. 2 by 1 the whole square plus 3 upon root 2 the whole square plus 4 upon root 2 the whole square. How much you will get? 4 plus 9 by 2 plus 16 by 2. So 4 plus 25 by 2. So 25. How much it will come? Yeah, something, whatever the values you are getting, just add it. Okay. So 2 square, 4, 9 by 2 and 25 by 2. So and in this questions there was one value was there, another value was there, that is 5 cos 3t minus 30 degree. So these are also orthogonal to each other. I miss this point. So this and these are also orthogonal to each other. See, because this is m, this is n, both are equal, but here sine function is there, here cos function is there, then you have to check the phase. So phase are also equal, so orthogonal, and this these are also orthogonal. So 5 by root 2 the whole square will also get added, so you will get 25 by 2. So how much you are getting? You are getting approximately 54. 54 value will come. Okay, so DC is orthogonal to every sinusoidal function. This is a very important point, note it down. DC signal, DC is orthogonal to each, okay, DC is orthogonal to every orthogonal signal to every sinusoidal function. You will get the orthogonality. Yeah, write one question example. So one example is like that: if you have z of t is 2 sine 2t minus 4 sine 2t plus 30 degree. So whether it will be orthogonal or not, see, this is 2, this is 2. The functions, okay, m is 2, n is 2. So if it is coming, this value is sine, this value is sine. So, and your phi 1 is also not equal to phi 2. Here phi 1 is 0 and here phi 2 is 30 degree. Okay. So these two are not orthogonal signal. So how you will solve this signal for orthogonality? What you will do? You need to solve this particular question. So how you will solve it? You need to solve like this: 2 sine 2t minus 4 sine 2t plus 30 degree will be how much? Sine a plus cos b, sine a cos b plus cos a sine b. So sine 2t to sine cos 30 degree plus cos 2t cos 30 degree. Okay, so 2 sine 2t minus 4 sine 2t cos 30 degree is root 3 by 2 minus 4 cos, here sine will come, sine 30 degree is 1 by 2 and this is cos 2t. So overall what you are getting? 2 sine 2t minus 2 root 3 sine 2t minus 2 cos 2t. Now check the signal. These two are, and you can write like this: 2 minus 2 root 3 sine 2t. Make it like this because sine 2t is common, minus 2 cos 2t. And now see, sine function is there, cos function is there, m is 2 and n is 2, and phasor phi 1 is 0 and phi 2 is also 0. So these are orthogonal signal. So 2 minus 2 root 3 by root 2 the whole square minus, no, plus 2 by root 2 the whole square. So power will be this. So how much you will get? In a power 4 minus 8 root 3 a plus b the whole square. So a minus b the whole square. So it will be 4 into 3 divided by 2 plus 4 by 2. So 12 plus 4 is 16. 16 minus 8 root 3 by 2 plus 2. So 8 minus 4 root 3 plus 2. So 10 minus 4 root 3. You are getting your power 10 minus 4 root 3. Okay. So this is the beautiful concept, and if you want to guys, if you want to check the RMS value means or power, like I'm giving you one particular question, then you will understand. Yeah. Suppose you have a signal like this. You need to find the power or RMS value of this signal. This is your signal. It's coming like this. It's going up, coming like this. It's going up. It's coming like this. It's going up. It's coming like this. So it's repeating. This things is repeating. Okay. So how can we break this kind of a signal? And this is repeating that side and this is repeating that side. So if you will break this into two part, suppose this is A naught is given as a 6, this is minus A naught. Okay, this is your T naught by 2, this is your T naught. Okay, so if I am breaking these things in a two part like this, see, if I am breaking this into two part, means I am just separating my square part and triangle part. So if I'll separate my square part, so here no square is there, here no square is there, here no square is there, here no square is there. I'm getting one particular signal like this. And if I'll separate my triangular part, so I will get one particular triangle here, one particular triangle here, one particular triangle here. Okay. And if I am adding these particular things, I am getting same signal like the first one. So now if these two signals are orthogonal, then the thing is done. Okay, and for orthogonal, what you have to check, this is your x1 of t and this is your x2 of t. Let me check my battery. Okay, yeah, so these two signal are orthogonal, guys. Okay, these two signals are orthogonal. How so? For orthogonal, what we have to do, we just have to multiply this. If you will multiply this and this, what you will get? 0 will come. If the area is coming 0, then your x1 of t and x2 of t signals multiplication is 0. And we need to find the power of this signal. Okay, now the thing is easy. Okay, power of this signal will be how much? What will be the RMS value of this? A naught by 1 the whole square into what is the time period? Means up to what time period? This is t by 2 and this is t. So for t by 2 time period it's active and overall time period is t. So it's coming how much? A naught square by 2. For this, what will the power? A naught by root 3 to up to what time it is active? T by 2 only, and overall time period is t, and this is square. So you will get A naught square by 3 into 2. So 1 is coming a naught square by 6 plus a naught square by 2. So these things you will get it very easily. And a naught value is 6. So 36 upon 6 plus 36 upon 2. So this is 6. This is 18. 18 plus 6 is 24. You can find the RMS value directly here also. Root under RMS value will be a naught by root 3 the whole square into t by 2 active period, a naught by 1 the whole square into t by 2 active period overall time period divide t. So, and if you will square this, you will get the power also directly. Okay, but why I did these things separately? I just separated these things because if I have a x1 of t signal and x2 of 2 signal, and if the product I am getting 0, this 0 will multiplied with this particular part is multiplied with 0 part, the overall area I will get 0. So these both two signals are orthogonal. Separately I find the power of this signal, separately I find the power of this signal, and I add it, so I get the result. Okay, so your x of t signal can be written as x1 of t plus x2 of t. So this was your x of t signal, and this is your x1 of t signal, and this is your x2 of 2 signal. And why? Because 0 to t naught x1 of t into x2 of t into dt, 0 to t naught by 2, it is 0 dt plus t naught by 2 to t, it is 0 dt, because we had seen the area. This is t naught by 2, this is t, so it's coming 0. So overall product we are getting 0. That means both signal are orthogonal. So power can be written as P1 plus P2. So power of this signal, we got one signal we got a naught square by 2, and another signal we got a naught square by 6. So overall results we are getting 24. Okay, so this was the concept of orthogonality. Now we are moving to the next segment, that is signal identification, that is neither energy nor power signal, then energy signal, okay, periodic signal, non-periodic signal. So this is a very important topic, very important. Okay, so yeah, energy signal. Write the next topic, write the signal, write the topic name, that is signal identification. Signal identification. So in this we are going to start with any NP signal, neither energy nor power signal. So what is the meaning of a neither energy nor power signal? If magnitude of signal, if magnitude of signal is infinite at any instant of time, their signal will be neither energy, then signal will be neither energy nor power signal. Okay, we write it like this, any NP. So at any instant of time, if you are getting the magnitude of the signal as a infinite, at any instant of time. If the magnitude of the signal is infinite, then the signal will be neither energy nor power signal. So for example, x of t is 2t 2 e power 2t. Okay, e power 2t into u of t. So how will be the signal look like? Somewhat like this. So at some particular time it's reaching to infinite. So at what kind of a signal is this? Neither energy nor power signal. Second, I will give you the example of x of t, that is r of t signal, r of t, and it can be written as tu of t. Okay, tu of t signal means it's going like this, straight. So at some particular instant of a time it will reach infinite. So this is also neither energy nor power signal. Okay, and one small example you can write like x of t is tan t. Signal is look like this. So this is also neither energy nor power signal. And fourth one is x of t e power minus t. So okay, so e power minus infinite you will get 0, but e power minus of minus infinite, what you will get? E power infinite, that is infinite only. So your signal is like this. So this is also neither energy nor power signal. Write the next heading, energy signal. Energy signal. So what do you mean by energy signal? I already discussed. Energy signal will have finite duration. Finite duration signal means it will have finite duration, having finite magnitude, and finite magnitude. So finite duration signal having finite magnitude are called as energy signal. For example, you have some particular signal like this. It's a rectangular signal. So from -2 to 2. This is your x of t. This is 4. So this is my energy signal because I have the finite durations. And what is the formula for finding the energy? We already discussed, minus infinite to infinite, mod of x of t. Mod of x of t the whole square into dt. And from what value you are getting these things? From -2 to 2. And mod of this value will be 4 the whole square into dt. So what will the energy will come? -2 to 2, 16 into dt. So after solving this, what you will get? 16 into 2 plus 2. So that will be 64. And you can directly do like this. 4 square into what is the time period? 4. So 64. Directly you can solve it like this. How? See, this is a rectangular pulse. So for rectangular pulse, we need to divide by 1. If the signal was like that, sinusoidal signal like that, -2 to 2, 4. So what will be the energy of this kind of a signal? 4 by √2 the whole square. What is the overall time? 4. So it will be 64 by 2 into 4. 64 by 2 overall. So you will get 32. And if the signal is like that triangular, then you need to divide by √3. Whatever the time period, just multiply it and square it. You will get the result. You can do with this process also, you can do with this process also, it's up to you. I'm giving you one particular another example. You have a energy signal like this, like this, like this is your energy signal. So from -2 to 1, this value is 2, this value is 4, and this is T. So what will be the energy of this? You can go with this process. So from here to here, from here to here, it's up to you. It's up to you. So how can you break these things? So for solving this, you need to find the equations like okay, -2 to 0, I have x of t the whole square into dt. Again, from 0 to 1, x of t the whole square into dt. Okay, so see, this is the energy. Okay, and energy x of t the whole square, for this part it's okay, 2 the whole square -2 to 0 into dt, it's okay. But what about this x of t? How you will know the value of the x of t? For this you need to find the m value. And what is the m value? y2 minus y1 divided by x2 minus x1. So y2 is my how much? 4, and y1 is 2. 4 minus 2 divided by x2 minus x1. So x2 is 2, x1 is 0, so 1. So how much we are getting? 2. 2t. 2t will come. So 2t the whole square into dt, 0 to 1. So 4 t cube by 3, 0 to 1, plus 4 into 2. So total energy will be 8 plus 4 by 3. 8 plus 4 by 3. And yeah. Okay. So this is the slow part. So by this way you can solve this kind of a circuit, this kind of a signals, energy and power signals. So this is the way to solve. It means you for solving this you need to find the equation, solve the equation and get the equations. So this part equations, okay, slope, I got the slope. Okay, and another example is if you have a example like this, means if you have a signal like this, this -2 0, this is 2. So at infinite this is going to infinite, so this is neither energy nor power signal, neither energy nor power signal. Okay, note it down. If magnitude or peak magnitude of infinite extension signal is either left sided or right sided or both sided decreasing. Okay, decreasing in nature from a finite value their signal will be energy signal. Their signal will signal will be energy signal. It's then signal will be energy signal.